Good evening, everyone. In the last session, we have ended with a topic that is reflection of light. Now, in this section, we are going to discuss the further topic of regarding this. So, the last session, we have came across that for the reflecting surface is necessary. And the last lecture only, I have already introduced you that reflecting surface is taken as a mirror. The mirror is our next topic. So, what is mirror? So, I will define the mirror as a reflecting surface on which the light reflects. So, mirror is a reflecting surface on which light undergoes the reflection. Light undergoes the reflection. The mirror further divided into the two types, in which the first type is type of mirror. The first type of mirror is the plane mirror, and the second type of mirror is the spherical mirror. Spherical mirror. So this is the two types of mirror that we are going to study further in this section. When we are talking about the plane mirror, let us start with the plane mirror. When we are talking about the plane mirror is that reflecting surface that we use in our day-to-day life in the morning. The plane mirror, we can draw the plane mirror like this way. The first topic is plane mirror. If I have to draw the plane mirror, then I will draw it like this way. So this is the plane mirror, in which the one side is reflecting and the other one side is the coated with a silver material. The plane mirror, in this section, the light come and reflected back from the plane mirror from the reflecting surface. So in this way, light come across and undergoes the reflection from the plane mirror. When we are talking about the plane mirror, I will show you how the image is formed in the plane mirror. Suppose this is the plane mirror, and in front of the mirror I will draw an object AB like this. As we all know that this plane mirror form the image, but how the image is formed, that we are going to demonstrate in this ray diagram method. When one ray of light after passing this object is collided on the reflecting surface of this plane mirror, according to the laws of reflection we already discussed in the last lecture, this ray of light is perpendicular to this surface. According to laws of reflection, it will goes back and traces the same path after the reflection, like this way. So this is the incident ray of light. After crossing the object, according to laws of reflection, it will undergo the reflection, and the reflection is happen like this way. It will trace the same path behind. Now I will take the second ray of light, second incident ray of light. Second incident ray of light also undergoes the also after passing this object like this way. This is the incident ray of light, second incident ray of light. After the reflection, according to the laws of reflection, it will be reflected back. When it is reflected, if you consider this as normal, the angle of incidence will be equal to the angle of reflection that we already discussed in the laws of reflection, right? So in this way it's reflected back. Now the thing is that where the image form and how does it form. We already studied in the till 10th that the image will be formed only when the reflected ray of light will meet with each other at some point. At that point, the image will be formed. So here, the one reflected ray of light is here, and the other one reflected light is here. If we try to meet them at any point, it is not possible, right? Because the one ray of light, one reflected ray of light is go like this way, and another one is go like this way. It is like the actual path of light will not going to meet at any point. But if I will extend the apparent part of this reflected light behind the mirror like this way, what I'm doing, I just extend the apparent part of this reflected ray behind the mirror. Also, I will do it with this ray of light also. The apparent part of this reflected ray, I will extend like this way. Now we can see that the apparent part of both the reflected ray is meeting behind the mirror. And according to the behavior of light, where does this two ray of light reflected ray does meet? At that point, the image is formed. So at that point, this ray of light is meeting. That's why here the image is formed in this point. I will mark it as A dash, B dash. Here, the 2 to 3 things we have to notice. That the first point is the size of the object and the size of the image will be same. This is the first point. Size of object and image both are same. This is the first point. The second point is the object distance. It means that the distance between the mirror and the object, that is object distance. And the second one is the image distance. The distance between the mirror and object, that is the image distance. Both are same. In the figure, it will not seem like this. Both distances are not equal because of the man-made error. But in the real situation, the image object distance and image distance both will be the equal. That is the second point. The object distance is equal to the image distance. And the last and important point is that the nature of image. The image formed here is of the type virtual and direct image. That is the third point. The image form is virtual and erect image. So what is this virtual and erect image? I will explain it. The virtual image is that image which is not formed by the actual meeting of the ray of light. As we already explained here, the image is formed because of the apparent part of this reflected ray of light, not real part. Apparent part of this ray of light is meeting here, and after that image is formed. In this condition, the virtual image is formed. When the real part of the image, if the real part of this image is this, the real part of this light this, if these two rays of light, if it's meet, then the real image is formed. But it's not going to happen here. The apparent part is meeting here, then image is formed. That's why it's a virtual image. The another one is the erect image. The symmetry of this image formed here is the same as the symmetry of the object. Here the object is AB, here the image is A dash B dash. the symmetry of the both object and image is equal here. That's why it's a erect image. So in this way, this is the plane mirror and its characteristics. The one more important point is here that it is very important according to competitive rules. In the competitive exams, you will come across various problems regarding the two plane surface, two plane mirror. If I will kept two plane mirror like this way, this is the first plane mirror, this is the second plane mirror. These two plane mirror are meeting at this point. If I kept the object AB between these two plane surface making an angle theta, at that time how much images will be formed? This type of question they will ask you in the competitive exam. So there is some formula for this. The formula is number of image is equal to 360 upon theta. So this is the formula from which you can calculate the number of images formed in this situation. Okay, so this is one of the important topic in the plane mirror. Now the second topic is the spherical surface. On spherical mirror, the second type of reflecting surface. So second type is spherical mirror. From the name, it seems that the mirror in the sphere, right? So, why we call it as spherical mirror? That I am going to explain now. Spherical mirror, it is made up of the spherical surface, spherical 3D surface. That's why it's known as, it's named as the spherical mirror. So how does it form? Now, first of all, I will take a 3D spherical surface. This is the 3D spherical surface. Spherical surface, right? From this spherical surface, I am going to form the mirror. But the one condition is here that in this 3D spherical surface, I will make the inner surface, shiny and the outer surface coated. So this is the outer surface of this spherical surface, spherical mirror. I will coat the outer surface with some material like this, and the inner surface of this sphere will remain shiny. So this is the inner surface which is shining here. So this is, in this way I will arrange a 3D spherical surface in which the outer surface is coated. This is the coating, right? And inner surface is shiny. Now what I will do, I will remove this part of the mirror and just keep that much part. Now here, this mirror is formed in which the inner surface is shining and the outer surface is coated, right? So this type of mirror is known as the conical mirror, which is the first part of the first type of the spherical mirror. Now I will again take a 3D spherical surface like this way. This is also 3D spherical surface. Same 3D spherical surface. But in this now I will get some different condition. Now I will coated the inner surface like this way. I will coated the inner surface like this way, and the outer surface will remain shiny. This is the outer surface which will remain shiny, right? Whatever we were did in this condition, just we have to do opposite in this condition. Now in this condition, the inner surface will be coated and the outer surface will be shiny, right? Now in this condition, I will remove that much part like this way. Here, the mirror form is known as the convex mirror. Here again, we form the mirror from the spherical surface, and this mirror in which the outer surface is shiny and inner surface is the coated. This mirror is known as the convex mirror. So this is the two types of spherical mirror. Does anyone have doubt? So this is two mirror that we are going to study in depth further with respect to reflection. To study these two mirror, we have to first learn about the rules of image formation. And it is a mirror. It also have the same. The purpose of mirror is to form the image. The image we are going to form because of the reflection, and these mirror obey some rules. That we are going to study in the next topic, that is the formation of image, rules of formation of image. Before this topic, we need to study the part of this mirror. So let's start with parts of the mirror. Parts of the mirror. So these two types of mirror have the parts. The first is concave mirror, right? And the second one is convex mirror. We all already discussed that this mirror is formed from the spherical surface. As this is the spherical surface, the sphere must have some center. Suppose the center of this spherical surface is here. So this point is known as the marked as a C and is known as the center of curvature. Center of curvature. It is the center of the spherical surface from which this mirror is formed. Now the second part is P, that is pole. The geometrical axis of this mirror is marked as a pole. Geometrical axis of this mirror is marked as a pole. Here the same thing is. The center of this spherical surface, if it is here, then it is the center of curvature, and the geometrical axis of this mirror is pole. If I will join these 2 points like this way, they form principal axis. So here CP is principal axis. Here also CP is principal axis, right? If I will name this surface as A dash, here also A dash, this A dash whole part is known as aperture. So A dash is the aperture. Then another part is focus, principal focus. That's marked as a capital F. Here also principal focus that marked as a capital F. So this is the point on the principal axis. So how we will define this principal focus? If the parallel ray of light, this is the ray of light which is parallel to principal axis. After the reflection, it will pass through the single point like this way. That single point is known as the principal focus. Here also, this is the parallel ray of light, which is parallel to the principal axis. This is the ray of light which is parallel to the principal axis. As this convex mirror is a diverging mirror, convex mirror is the diverging mirror, and the concave mirror is the converging mirror. Why we call it like that? As I already explained, concave mirror is a converging mirror because it's converge ray of light. After the reflection, the ray of light is converging. It is concentrated at a single point. That's why it's a converging mirror. But the convex mirror diverges the ray of light. Here, after the reflection, the light gets spread out like this. So here, after reflection, the incident ray of light reflected and diverged. Here also, ray of light reflected and diverged, right? But if I will take the apparent part of this mirror and extend it further, here also, if I will take the apparent part of this mirror and extend it further, it will going to coincide in the single point, and that point is not the principal focus. So here F is the principal focus, and that's why this mirror is known as a divergent mirror. This is the next part F, which is the principal focus, and the last one part is small f, that is the focal length. Focal length. The distance between the pole and the principal focus, distance between the pole and principal focus is known as the focal length. So these all are the part of the mirror. So till now we are discussing about the reflecting surface, its type, that is plane mirror and spherical mirror, the spherical mirror further divided into the concave mirror and convex mirror. These all mirrors are obeying certain rules that we will discuss in the next topic, that is the rules of image formation. Should we pause for a minute?